Alright, in this video, I am going to go through part 2 of the building a content-based filtering model. So in this one, we're going to continue on in the same Colab. So if you scroll up to the top and you click on this link, we'll go ahead and start here. And if you're starting fresh for the day, you're going to have to run your libraries and import your song rating string. So make sure that you click this, click Run Anyway. Make sure you run that library import function, and then you'll need that song rating string, so make sure you have that. Actually, before you run this, what we'll need to do is we'll actually need to change these attributes. So just like we had to do for the first one, we want to make sure that these attributes are attributes that we think will best predict our song preferences. So for me, I know I like these upbeat songs. Tempo was one that I wanted to use because that's nice and upbeat. But then I think the other one that I wanted to use was energy. And I think the third one that would be pretty good at predicting mine would be the liveness. Okay, so I've got tempo, energy, and liveness. Those are the three attributes that I think are best going to predict my models. And then now I can run this, and then it'll ask me to paste in that string. So again, that comes from the rating string from that first rating collab that we did. You'll paste that in there, press enter. And now we are all set to move on to the next part. So again, we'll have to run this train test split and download our validation set data. So those are the songs that are going to be used to test and compare to the predictions. And then if you've already ran the one attribute model, you do not need to do that again. So you can go ahead, skip past that, and go right to the two attribute model. Now, what you'll notice with the two attribute model is that you have a very similar slider for complexity. So we can still go up in orders of complexity here, and we can go down. So if we do a single complexity, if we look, if you notice, this was a three-dimensional graph, because now, instead of just having like one x variable, now we have two x variables. So we have energy and we have tempo on the x-axis. And really it's an x and y axis, and then on the z axis is this predicted song rating. And you can see we no longer have a line because we're in three dimensions. So we actually have a plane that is going to be our predictor plane. So any points are on this plane, these would be like the predictors for a given energy level, so a song that has a certain energy level and a certain tempo. And you can see these these points in this three-dimensional space, these are just songs. So these are songs that I rated. They have a specific energy, they have a specific tempo, and they're plotted in this three-dimensional space. So it's kind of cool. You can navigate around that 3D space and see how the computer kind of generates this plane. And there is an equation for it. Now notice how we have two different x variables, so we have two different inputs for this function, and we still have just our one output, which is the predicted rating. Okay, now let's see what happens when we add some complexity. So just like when we added complexity in our two-dimensional model, we add complexity in our three-dimensional model, we're going to start to see a curve. So we should see one kind of U-shaped curve, and that will change our training error and our testing error. So the training error should go down. Testing error, we don't know. If the testing error goes down, then we're going to want to use that as our model. But it looks like when we did our single level of complexity, it was only 2.974. So a level of 2 was not any better. Let's check level 3. We get to level 3, and now we're at 5.83, and it's probably only going to get worse from there. So in this case, the single level of complexity looks like it's the best one for our model. All right, so that's your three-dimensional space. Again, it's kind of weird, but you have to really think about it. Look at these data points. You have two predictor variables, one target variable. So we have an x variable, a y variable, and then we have z, which is our target variable. That's what we're going to be predicting. Again, it's still the song rating. So with more data, we should get a better prediction, and let's actually see how this works. So I chose my model, again, based on having the lowest testing error. And now I can go in and so if we go, we check the testing site. So this is just my training data. So now when I run the second one, this is actually showing how it compares to my testing data. Ooh, so it doesn't look like it's the best, but it's the best out of all of the levels of complexity. So now we're going to go ahead, just like what we did for part 1, we're going to play a song, and this time we're going to use the 2 variables, the 2 inputs, to predict the song rating, and we'll see if it's a little bit more accurate. So I'll press enter. And then 8.22, that's a little bit high. I don't think I would give that an 8.22. I would probably give it more like around a 6 or a 7. So in this case here, the 2 attribute model wasn't as good. Normally it should be better, and so hopefully for your guys' your model got a little bit better at predicting your song rating.